Hi guys, in this video we are going to learn about absolute error as well as relative error. In the previous video we have learned about the approximation. So here we are going to look about what's the error we are going to get after that approximation, whether we can use that approximation, is it a suitable approximation. So how we are going to find this? We are going to check the error. If the error is less, we can tell that it's okay to approximate at that point. So for that reason, we are having two types of error. One is absolute error. The second part is relative error. When you are considering about the absolute error, actually we are going to find the true value and we are going to deduct approximate value we have already approximated, and we are going to find what's the difference between those two values. So we are going to call that absolute error. Likewise, when you are considering about the relative error, we are going to divide that absolute error by true part, the true value. The reason is we are going to check how much it differs, how much the error we are getting in relative to that true value. So according to that true value, related to that true value, whether that error we have got is higher or less. So we are going to relate with that true value. So that's known as relative error. So these are the two equations you need to know. So now we can look at an example. So let's say the question is find the relative error and absolute error for 5-digit chopping of 5. So 5-digit chopping of 5. So what they are asking is we need to find the approximation of 5-digit chopping of pi, and after that we need to calculate the absolute error as well as relative error. For this purpose, we need to find what's the value of pi first. Otherwise, we can't actually chop that. So for that person, you can actually use your calculators. Otherwise, you can use the Google. So if I use the calculator, I'm going to get some values. So I'm going to write that 3.141592654. It's going to continue. So I hope you have got a clear idea about that. So please pause the video and try it in your own. I hope you can easily do that. So please try it in your own. I hope you have given your maximum try and get the correct answer. And let's check whether we all are getting the same answer. Let's try that. So when you are doing about the chopping or rounding off method, which is an approximation, actually you need to, first of all, you need to change this part for the normalized form. So we have already learned in the previous video, the approximation is defined to normalized form. So when you are writing about the normalized form, we need to put this 0 first, and we are going to write it like this. 5, 4, we need to multiply by 10 to the power 1 to get this real value. So we have changed for normalized form. After that, we can count the 5 digits. So if we count the 5 digits, it's going to be the first digit, it's going to be the second, third, fourth, fifth. So actually we knew that if we are using the 5-digit chopping, we can actually cut down after the 5th digit. So I'm going to draw a line and just cut it off. So the balance part is going to be 3.1415 into 10. So if I do that approximation, it's going to be 3.1415. So now we got the approximation using 5-digit chopping of pi. However, this is not the question. So here we need to find absolute error as well as relative error. So let's move to the absolute error part. So for the absolute error, we need to find the modulus of true minus approximate value. So here, what's the true value? Is that the same thing, 3.141592654? So some might think pi is an infinite number. You can actually cut it down up to this digit and tell this is a true value. But the thing is, we are going to compare with the approximate value, which is only having 5 digits. Shopping, we have used up to 5 digits. So it's enough to use the true value, which is having more than 5 digits. You don't need to take all the things, all the values. So actually we can't get a clear idea. It's very difficult if we are having an infinite number for infinite digits for pi. So what we are going to do is, we are having up to this point. So let's write it up to this point. So if I write like this, the true value would be 3.141592654. If you want, you can put this dots also. So however, I'm not going to write like this. So let's minus the approximate value is going to be 3.1415. So now we need to find the difference between these two values. So I'm going to use my calculator. 3.1415. I'm going to get 9.2653. Let's stop until this point. Line 35. If we approximate this, I'm going to get 6 into 10 to the power minus 5. So this is the absolute error. As you can see, it's having 10 to the power minus 1, so it's very small digit. So that's fine. So the error is acceptable. It's very small. According to purpose, we need to check whether the purpose is to find anything else. So we need to find the purpose of that person, and we can tell whether this error is enough or it's okay to use this approximation. So likewise, I'm going to find the relative error in terms of the true value. So actually we have found the value of true minus approximate, which is 9.26536 into 10 to the power of minus 5. We need to divide it by this actual number. I'm going to write the whole value 141592654. So now also I'm going to use the calculator. So we are going to have the value of 2.949255 into 10 to the power minus 5. So this is the relative error and this is the absolute error. So actually you can see some relationship between that. When we are considering about the absolute error, it's little bit 9. It's like 10 to the power minus 4. If you take approximate to 10, it's like 10 to the power minus 4. However, when you are seeing this relative error, it's showing a lesser value. So it's not mean that always relative error, we need to take relative error. It's if the absolute error is very less, it's enough to use that. So actually it depends on the purpose of the process. I hope it makes sense. So in the next video, we are going to look at some calculation further. So if you have any doubts, please comment it below. Thank you for watching.